Yes, sir, you can start.
Okay. रिकॉर्डिंग आप कर रहे हो क्या?
जी YouTube लाइव हुआ है सर.
लाइव है. थैंक्स अ लॉट.
Thank you, sir.
Hello, hi to all the young engineers and students who are just passing out from their engineering colleges. In our audience, we have graduate engineers, diploma engineers in mechanical, electrical, and electronics. First of all, welcome to the Skill Edge Get Edge program of skill development. What we mean by this is Get Edge means graduate engineer trainee Edge program, which is primarily designed for skill development. Friends, my today's session is on turning, CNC turning, which is the most important CNC operation and widely spread operation in any manufacturing industry you're going to go. So the knowledge of CNC turning is going to be very, very essential skill development. Before I start, let me introduce myself. I'm DK Mohan, a manufacturing industry expert with more than 3 decades of experience in manufacturing, production, machining, overall administration, quality, looking after the whole company, sales, marketing, brand building, dealer management, team management, growth and profitability. So I've seen the industry for the last 3 decades very, very closely. All of you have achieved your first step of being a graduate or a diploma. All of you are now qualified engineers. But to get a job or to make a career, you have to differentiate yourself from others. And the only differentiation can be skill development. All students today have a resume in which you have the your BE or diploma qualification, first year marks, second year marks, CGPA and all. You also write 2-3 sentences about your projects. That's it. But important is the industry is looking for some skills. Industry is looking for some knowledge where you can implement that knowledge immediately the moment you join. That will be a differentiating factor for you between a job and a career. We are there to make your career. In this Skill Edge program, Get Edge program, we are covering manufacturing technologies, lean manufacturing, new product development, welding technologies, mechatronics, design and quality, and problem solving, and new product development. In this, I'll be taking your manufacturing module, where we are going to discuss about various manufacturing processes, casting, forging, powder metallurgy and all. We are also going to discuss machining processes, CNC turning, milling, drilling, machining economics, quality and relation to drawing. You read drawing as a subject, GD&T in your college, but I'm going to teach you how in an industrial perspective, the design is directly related to the quality of the product. The drawings have to be interpreted in such a way that you make the best product in the tolerances specified in the drawing. Then only you can come out with a very, very good product. So among the different 11 modules, which also include machining economics and also include Industry 4.0, my today's session will be mainly on CNC turning. predominantly, if you see in a manufacturing setup, first of all, CNCs are there in today 70-80% of the manufacturing industries. Only small shed type companies do conventional machining, but otherwise all the good grown big companies rely on their production only because of CNC machining. The best part of CNC machining is it gives a very good quality, it gives very good consistency, and it also ensures that your productivity levels are very, very high. The earlier programs which were done manually by the operators, when say taper turning or profile milling, profile turning and all, it used to require a lot of skills from the operator, and the tools were predominantly specials. But today with CNC, all the tools are standard and you can do by programming any type of profile. As you know, in CNC, we have got only two axes generally, X and Z. Any movement of the tool along the axis of the job is actually called as Z axis, and any movement radially into the job is called X axis. So in today's contents for CNC turning, we have the following 5. We'll discuss in brief about various type of lathes, their generations, what is a conventional lathe, copying lathe, hydraulic lathe. There's so many types of lathe. Then the generation changed to DRO, digital readout. Then we are talking of CNC turning machines, and then CNC turning centers. CNC turning centers have got extremely high versatility, adaptability, and they can perform work of 3-4 CNC machines. You can attach a drilling attachment, you can put a milling attachment, and then CNC turning center is a very, very latest generation where you should know how it operates. We'll also cover on tungsten carbide. 99% of the tools involved in CNC are tungsten carbide tools. They are throwaway insert type tool holders and inserts. So we'll discuss all type of CNC inserts for turning, parting, grooving, profiling, facing and all. We'll discuss the types of inserts, how they are selected, what are their strengths and weaknesses, okay? And then we'll also talk of ISO classification. We'll also discuss CNC tool holders, PCLNR 2525, M12 and similar, so many things are there. Different type of ISO tool holders available, their selection, their criteria, how the approach angle matters. We'll go into detail of this. Selection of cutting parameters and grade of carbide is very, very important. Because final machining is done when the tool penetrates into the job. I'll discuss the importance of speed, feed, depth of cut, power requirement, specific cutting force. What are the different grades of carbides in ISO classification? Steel, stainless steel, cast iron, all type of tools, how the grade is selected. In carbide specifically, what are the grades? Hard grade, tough grade, medium grade, how the brittleness, how the toughness, how the impact affects the performance of the tools. Examples of CNC turning we'll take where we will see how a shaft from a raw material to a finished product, how it can be machined. For example, if I talk of raw material, 65 mm diameter, 3 meter long, you took from the stores. The material is EN19. So here you have to convert this into dia 60 collar up to 20 mm length, M16 into 1.5 pitch, 18 mm length, dia 40, 125 mm length, dia 24, 12 mm length. Here I'm going to teach you all the types of operations involved, machine selection, tool holder selection, insert selection, cutting parameters, how many rough passes, how many finish passes, how the cutting speed, what do you mean by constant cutting speed and what do you mean by variable cutting speed or constant RPM. All these fundamental knowledge is very, very important for you to make a career. So we are going to discuss, and I'm confident, and we also will help you in some CNC programming. What are M codes? What are G codes? How all this is done in a programming setup. So taking a live example from industrial point of view, I'm going to teach you the total process of CNC turning. The value addition, if you attend this course, will be that you will be able to write down the steps of the processes involved. You'll be able to select a good tool holder for doing the operation, a good carbide insert with different, whatever is the toughness, hardness based on roughing and finishing. I'll also teach you the machining economics and how much time it can take on from a raw material to conversion into this finished product as shown in the diagram above. We'll also see how we can help you in calculating the cost of the turning, because finally machining economic means you have to take maximum utility of the CNC lathe. Today, a CNC lathe costing 1,500 rupees per hour or maybe 1,000 rupees per hour. You have to utilize the machine to the best possible extent with the optimized cutting tools and cutting tool parameters. So I welcome all of you for this CNC turning class. And yes, we can develop this skill and face the interviews very, very confidently. Thank you. Best of luck. Looking forward to all of you in my actual session of CNC turning. Thank you. Goodbye.